It's not so mad at me that it won't record. All right, so the final thing that we want to do is we want to clock the physics cannon. Now, you guys, when you go to Home Depot, you probably buy things for your house, right? But when I go to Home Depot, as I did one time before, I usually go with, I've got something in mind that I want to build. And so basically I went to Home Depot with a tennis ball, and I went to the plumbing section, and 3-inch pipe was too small, I believe, for the tennis ball to fit in, and 4-inch pipe was too big, so I needed something in between. Then I went to the electrical section, and gray electrical conduit comes in 1/2-inch sizes. I believe this is 3.5-inch, okay? And the tennis ball fits in there real nice. It's got to fit in really snugly. Okay, I'm trying to avoid saying snugly. Okay, and then the problem with the old cannon was that the thing actually developed a crack right here. There was a possibility that it would like burst and send little flinders of shrapnel into students, which was a sort of a minor drawback, right? And so this one, the new one, I've got this metal cloth on there with the idea that if it does burst, it'll just sort of not send chunks of metal or something like that around. And then here I've got I think this is a 4-inch clean out. And then inside there, I've got a couple wires, and I'm going to hit it with the same thing I did for the methanol cannon thing there. And inside there, there's a couple wires, and it's going to be like an electrical spark kind of a thing. Okay? Okay. Now, the question is, how fast is that cannonball going when it leaves the end there? And we used to try to just time it, like, okay, there it goes, and we try to see how long it takes it to go 5 feet or something like that. But the answer to that was just like lickety-split. It's like, oh, I can't even see it, right? So what we realized was that this thing's on wheels, and when the cannonball goes that way, the cannon recoils and goes the other way, yes? Yes. Okay? So we can, if we ignore minus signs, we can actually set up a formula, right? Really what's going on is that the cannon has some mass and the tennis ball has some mass, right? And before the explosion, it had 0 momentum. Afterwards, it's mass of the cannon, velocity of the cannon, plus the mass of the ball, velocity of the ball. So if the ball has a positive velocity, the cannon will get a negative velocity. We've solved this momentum problem. Okay. Now, if we ignore the minus signs, this means that we can solve for the velocity of the ball is just the mass of the cannon, velocity of the cannon divided by the mass of the ball, right? So that's one thing, right? I'm ignoring the minus sign. If you want the minus sign in there, just put it's minus that, is what it really is, right? Okay? Now, the second thing that we can do is we can time how long it takes this cannon to coast to a stop. Okay? It's going to be moving and then it's going to coast to a stop. That's a simple Suvat formula. The initial velocity is what we want. The final velocity is 0, right? And we know the displacement, and all we want, and we know the time, right? We can measure the time. So what's the formula? Which one do we want to use?
S equals V.
Yeah, that's the one, right? Okay, so we're going to say S is U plus V over 2 times T, yes?
Yes.
Okay, so that's the basic formula, but what we're going to do is we're going to solve that for the initial velocity. So the final is 0, right? Well, if you do that, the velocity of the cannon, right? The velocity of the cannon is just 2s divided by t, yes? Isn't it? She's going to go study to be like on the Iron Chef or something like that. Yeah? Along with Fabula, apparently. Did you guys hear the announcements this morning? Matt said Fabiola's name, Fabula. So that became her name in class. Hey, Fabula. That's her stage name when she's famous. It's like, okay. So this is going to be our velocity of the cannon, right? Okay. And what we're going to do is we're going to go out in the hall and fire this thing off, and we're going to try not to kill somebody. Okay. And so what we'll do, I wonder if we should, with lunch going on, if we should just, yeah, let's do it. We'll just do it right out here. We'll scare everybody in this hall. Okay. But what we're going to do is we need a couple people to time. Okay, I need 2 timers. I need someone when I'm going to go on your mark, get set, and then light it off, and it'll go boom. Okay? And I need 2 people to time it from when it goes boom to when it stops. Who will that be? Erica. Hand? We need the other Erica to do it, because then we can just say, Erica's, are you ready?
Yeah.
Right? Okay. Then we need somebody to measure the distance. And this has to be somebody with eyes and hands.
Not me.
Eyes and hands. Could it be you? It could be you. All right. I need somebody to place the targets in front of the thing. This will not be a live fire exercise. Who wants to be in charge of the targets? Now, okay, good. He accepted the job before I told him the entire job description. Sometimes the cannonball lights the boxes on fire, and if you deem them to be on fire, okay, you have to, say something, but the main thing is carry them outside before they are engulfed in flames and throw them outside. Okay?
That's safe.
That's safe. Yeah, it is. Okay, this has happened, I don't know, 3 or 4 times in the entire history, but this is a notable thing. And then we also need some people to stand. We're going to fire it down this hall toward those doors, and we don't want any pathways people walking out in front of it. Okay, so some people need to stand in that little pathways hallway, this hallway right there. Okay, and just warn them. Okay, that there's a little live fire exercise going on out in the hall there. Yeah. Okay. And then okay. I'm going to do it right here in this hall, just because lunch is going on. Should I?
Yes.
I think I definitely will.
I can hug you right now.
Okay. You got it?
What should I do with this?
You're going to carry that in the hall.
Is he gonna joust people down?
Yeah, would you?
Hey, is he gonna joust people down or something?
Okay. Where's my hearing protection? Here it is. I got it. Oh, I need a scribe. I need somebody who will write down the results of the experiment, the distances and the times. You want to do that? All right.
Actually, that would probably work a lot better than that.
There you go.
I got a pencil, thank you.
Oh, okay. You're going to do it on paper.
Yes. I hate planet Earth, so I have to use something non-recyclable.
All right.
You know what I did in Mother Nature? I gave her a bad Mother's Day card.
Well, that's not very nice.
I don't like Mother Nature much.
Okay, where did my... There it is. I see it.
What am I timing? Hurry.
There's
And you have to have a really now. Wait, so what am I timing?
Okay, let's mark. Okay, where are the timers? Everybody stand against the walls on either side.
What am I timing?
You're going to time from when it goes boom to when it stops. Okay? Notice it's on this line here, so we're going to keep this guy here to mark that line.
Do we need to put the targets over here?
Targets need to go down here. Where are the targets?
Aaron.
It's your time to shine.
He's like,
Come on out. Keep coming out. Stand against the walls. There we go. Put the targets up here. How about right here? And then I need some people to stand in the pathways hall here. Right there. There you go. Let's not use that, but let's use this guy. There you go. Just give them a heads up if they come out of there. Yeah.
the distance it can move timer 1.
Yeah, and we're going to do 2 trials if we can. All right.
So when the tennis ball stops?
Okay, where are my timers? There we go. Okay, I'm going to go on your mark, get set, and it's going to go boom, right? And you're going to time from then to when it stops moving.
To when what's
Okay?
this thing?
That thing, yeah. Now notice that the wheel is right on this line right there, or will be when we set it off.